Welcome back to Low Stress Math with Mrs. Bono. We are in Book 3, Chapter 6, Transformations, Lesson 4, Reflections. All right, I'd like you to take a look at these two figures and list any differences or similarities you notice between the two triangles. Let's start with you do the work. I'll take a nap. No, silly Bono. Are you back? Did you pause the video? Did you do the work? Let's hope. All right, let's look at these two shapes. Now, if I look at this angle A and this angle A prime, that's the same angle. That's a right angle. And from A to C is 1, 2, 3. 1, 2, 3. From A to B, 1, 2, 3. A prime to B prime, 1, 2, 3. On a diagonal, 3 diagonals. On a diagonal. These two are the same size. And they're the same shape. What is it when they're the same size and the same shape? Oh yeah, these are congruent figures. So A to B to C, triangle, ABC is congruent. Remember the symbol for congruent. Similar means the same shape. Equals means the same size. So remember, equal is the same size. Tilde is the same shape. Put them together, you get a congruent symbol. 2, triangle, A prime, B prime, C prime. Now, you might notice that they are in two different locations. The one is to the right of the y-axis, one's to the left of the y-axis. Now, they're also not pointed in the same direction. The C is pointed to the right, the C prime is pointed to the left. So orientation has changed. Orientation is kind of a fancy way of saying direction, so we're just going to write that. All right, so the location is different, the orientation is different, but the size and shape are the same. And we're going over the y-axis. We have flipped over. How do I know it's the y? Because they're the same distance to the y, but on opposite sides. All right, so a reflection, let me move this all the way up. Here we go. Flips a figure over a line of reflection. Sometimes I'll call it a line of symmetry, but I'm going to stick to line of reflection in order to create a mirror image where everything is the same but on the opposite side. If you raise your hand in a mirror, say you raise your right hand, the reflection you see is raising their left hand. So take a look in a mirror and see that sometimes. It's kind of interesting. Right. Each reflected point of the figure should be the same distance from the line of reflection. But, big but, on the opposite side. So it's going to be the same distance to the line, but the opposite side. Let's take a look at that. Here's A. A is 1, 2, 3, 4 boxes to the line. 1, 2, 3, 4 boxes on the opposite side of the line is A prime. B is also 4 boxes to the line, and B prime is 4 boxes to the opposite side of the line. C is 1 box, C prime is 1 box. So it's the same distance, but on the opposite side of the line. Now, reflections are also called, I call it a flip. Some people call it a mirror image. Mostly flips. All right. Orientation changes. Oh, now look, I wrote in the wrong box. I wanted to write that down here. Orientation changes. But what's the symbol? The symbol is making a mess, Bono. Come on, whiteout work. Da, da, da. There we go. Lots of good whiteout. The symbol is a little r, and then they'll usually write the line of reflection down here. So in our case, up here, we flipped over the y-axis. So that would be a little r, and then y-axis. You can also, little r, the x-axis. But that's not all. Sometimes you flip over a line that is not an axis, but say x equals 1 or y equals -3. You can flip over other lines. We're not going to for a while, but you can do that. All right. So the rule, if you're going over the x-axis, you're going to take the x and leave it alone, keep it. But the y, you're going to multiply that times -1. So change the sign of the y coordinate. Now, the r, when you go over the y-axis, you're going to multiply the x times -1 and keep the y. That means you're changing the sign of the x coordinate. And I am ignoring this because I don't teach it that way, so let's just get rid of that altogether. Blah, blah, blah. Don't like it. All right. Let's take a look at this triangle. We're going to reflect it over the y-axis. So which one's y? Y is the vertical axis. And I'm going to flip it over that. So in other words, W is 1, 2 to the line. 1, 2 on the opposite side is W prime. X is 1, 2, 3, 4, 5, 6, 7 to the line. X prime is going to be 1, 2, 3, 4, 5, 6, 7 on the opposite side. X prime. And Y, also 2 to the line. Y prime will be 2 on the opposite side. So now what I need is my handy dandy ruler. I'm going to connect WX and Y with W prime, X prime, Y prime. You know what I mean. Making sure I get all of my little points connected here. Now, the pre-image, that's the original. This is the image, and this is the pre-image. Pre means before, so pre-image means before you do, come on, Bono, learn to spell, before you do the reflection. So, what's W? W is at 2, 6. X is at 7, 4. I should put my letters here, W, X, Y. 7, 4. And, wait, why do I have 2 W's? I don't even know what I'm doing. Silly, silly me. I guess I'm distracted by the fact that it's lunchtime and I haven't eaten yet. You know how chubby people are. We like our food. Here's Y. And Y is at 2, 2. Right, now what happened? Where are the images? Where is W prime and X prime and Y prime? Well, let's look at W. It's now at -2, +7, +6. What changed? Well, the only thing that changed was now I'm at -2. The 6 is the same. So I changed the sign of the X, and I kept the Y. The X does the same thing. X is at -7, 4. So the -7 is the change. 4 stays the same. And the Y, what happened with Y? Y is at -2, +2. So changed the sign, but kept the Y. Change the sign of the X, keep the Y. So describe what's happening. X values. You're going to change the sign. But what about the Y values? Well, you're not going to do anything to the Y values. You're going to keep it the same. Now, how do I write that algebraically? Sometimes I'll call it a rule, sometimes I'll say algebraically, but mostly it's just X, Y, and what's going to happen? I'm going to change that sign by multiplying -1 times X and keeping the Y the same. Multiplying by -1 changes the sign of the number. We're going to write a little bit more about that in a minute, but the way, if you want to change the sign of a number, you multiply by -1. All right, down here, I have, my shape is here, and I am flipping that over the X-axis. That is the X. So this is X, this is Y, and I'm flipping over X. So D is 2 to the X, so D prime is going to be 2 on the opposite side. E is 1, 2, 3, 4, 5, 6, 7 to the line, so 1, 2, 3, 4, 5, 6, 7 on the opposite side, E prime. And F prime, also 7 to the line, so 7 on the opposite side for F prime. And grab that silly ruler and make sure your lines are nice and straight because, yeah, it's easier for old people to see things if the lines are nice and straight. It's also easier for you to see whether or not your shapes are congruent. If all your lines are crooked, you can't really tell if something's congruent. But if it's nice and straight, you can see easily that these are congruent shapes. Okay, so pre-image. The pre-image is where I start. And the image is what I create. So the pre-image has D at +2, -2. Let's write those letters down before I forget them. And E is at +7, -7. And F is at +2, -7. Now, where's D prime? I'm going to write a little smaller over here. D prime and E prime and F prime. I almost wrote E twice. So D prime is at +2, +7. So the X value, 2, stayed the same, but now my Y value, which was 2, was -2, now it's +2. So what changed? Going over the X, my Y changed signs. So I'm just going to use that rule. 7 stayed, but -7 became +7. Ooh. Well, I probably should get rid of that. There we go. 2 stays the same. -7 becomes +7. So my signs change for the Y values. What happened to the X values? Nothing. They stayed the same. I keep my X value, and I'm going to change the sign of the Y. All right, how could I write that? Well, starting with X and Y, I'm going to keep the X, but I'm going to change the Y by multiplying times -1. And there's -1 times Y. So I have all this space here. Did you think it was an accident? No. To change the sign of a number, multiply by -1. I'm going to write it in red so you remember. -1. So let's do a couple of examples of that. -1 times -3. Negative times negative is positive, so -1 times -3 is +3. Change the sign from -3 to +3 by multiplying -1. -1 times +7. Negative times positive, -7. So multiplying by -1 is how you change the number. Please remember that reflections are flips. You're flipping over. Let's take a look at some more here. There we go. Use the reflection shown. Here's the Q prime, R prime, P prime. Write a verbal description. Well, what did I flip over? Here is my line of reflection, which I was going to highlight a little better. I reflected over the x-axis. No, Bono, you reflected over the y-axis. Y is vertical, x is horizontal. I'm going over the y. So reflect over the y-axis. That means I flipped. Flip over the y-axis. And remember we had that symbol back here on the page before? See the symbol? There's it go. There it is. R y-axis right there. That's how you would write it as a symbol. R y-axis. Sometimes I'll put that in parentheses, but it's really not supposed to be in parentheses, but it's how my mind works. So write an algebraic expression. What happened? X, y. When you flip over the y, change the sign of the x. So that means that I'm going to do -1 times x and keep the y. Now, this does not mean make it -x. It means negate it, change the sign. So that's multiply by -1x. And what's preserved? Size. What changed? Orientation. Okay, Isabella believes that this graph shows a translation, while Jonathan believes it's a reflection over the x-axis. Remember, this is the x-axis, and I'm thinking that maybe Jonathan is right. This isn't a slide down. If I slid it down, that L would be on top, but it's not. It's equidistance. So this is a reflection. So Jonathan is correct. The figure flipped over x. Oh, over the x-axis. So he's right. Triangle ABC has the coordinates shown. And look at this. This is really -1 times x. Remember, -x is the same as -1 times x, y. So what's the line of reflection? Well, when you change the x, you've reflected over y. So this is y-axis. And what do I have here? A prime, a B prime, a C prime. And what's changing? The x value is changing. So -1 times -4, +4. But I keep -6. -1 times -5 is +5. And I'm going to keep the -8. -1 times -1 is +1. And I'm keeping -3. So multiplying -1 times the x value is a flip over Y. In which quadrant will it be? Quadrants. I know how much you love those quadrants. I'm going to draw them. This is 1, this is 2, this is 3, and this is 4. Now 1, 1 is positive, positive. 2 is negative, positive. 3 is negative, negative. And 4 is positive, negative. And these are positive, negative. So these are all in quadrant 4. In example 6 through 8, use the description to identify the line of reflection. All right, this is XY. Come on, what's changing here? X has become negative X. Oh dear. But Y has stayed the same, negative 1, negative 1. So, change the X, it must be over the Y-axis. So when the X changes, it's over Y. Figure is going from 1 to 4. Oh dear. 1, 2, 3, that's not a 3, 4. And it's going from 1 to 4. So that's flipping over the X-axis. When you go over the X, you change the Y. So X, Y, you're changing, keeping the X, changing the Y, changing the sign of the Y. And for the last one, I have XY here. And I kept negative 5, that stayed, the X value stayed the same. And 7 went to negative 7. So that too is going over the X-axis. All right, so list any similarities or differences. Well, similarities. They're both congruent. The figure, the new image is congruent. To the pre-image. So in both, the images stay congruent. What else? Location changes for both. That's the similarity between translations and reflections. But only reflections change orientation. Well, that was nice. All right, so only reflections change orientation. And down here, this is a slide to the right and down. That's a translation. This, the A's are the closest, the D's are the closest. That's a reflection. So this is a flip, and this is a slide. All right, I will talk to you soon. Bye.